Hello students. So from today we are going to start our physics classes for class 9. So our first chapter is motion. In physics you have I think 6 chapter. So our first chapter is motion. So we start today. We are going to start our first chapter, that is motion. So what is motion? An object is said to be in motion if its position changes continuously with respect to a fixed origin. With respect to a fixed origin, that is called motion. What is distance? Distance is the total length covered by an object. Total length covered by an object. Suppose an object is in motion, the total length he have covered is called distance. The unit of the distance is meter. Distance is a scalar quantity. Distance cannot be zero. It doesn't have any direction. Distance have just only magnitude. Now what is displacement? The shortest distance from initial position of an object to its final position is called displacement. That means the final position, see here in the image, this is the initial position and this is the final position. If the object travels through this path, the shortest distance is the straight line between that initial and final position. This is called displacement. And similarly, the total length of that path is called distance. Now, displacement is a vector quantity. It can be positive, can be zero, can be negative. It has a magnitude and as well as direction. So displacement has direction with magnitude, and distance has only magnitude. So I have given a problem that a farmer moves along a boundary of a square field of side 10 meter in 40 seconds. What will be the distance covered by the farmer and the magnitude of the displacement in 20 seconds after starting the journey? So the farmer going to start his journey from the boundary only, and each side is 10 meter. Each side is 10 meter, and he takes 40 seconds to complete the boundary. So what will be the perimeter of the square field? The perimeter of the square field will be 4 into each side, that is 10 meters. So 4 into 10, that is 40 meter. So the velocity will be 40 meter by 40 seconds. So that will be 1 meter per second. After 20 seconds, the farmer crossed, that means 20 meter. We know from the velocity that if he covered 1 meter in 1 second, that means 20 meter he has covered in 20 seconds. As each side of the field is 10 meter, that means after 20 seconds the farmer is at point C, that means from A to B and B to C, that is 10 plus 10, that is 20 meter. 20 meter, the total displacement will be AC. Displacement means shortest distance from final and initial position. So initial position is A and final position is C. So shortest distance will be the diagonal of that square field. So how to calculate the diagonal? From the triangle ABC we can know the Pythagoras theorem, that is AC square plus AB square. AC square is equal to AB square plus BC square. So from that we can calculate the diagonal, the length of the diagonal. So that will be the displacement of the farmer. So next point is uniform motion. What is uniform motion? When an object covers equal distance, in equal time interval, it is said to be uniform motion. Example, motion of a clock hand. Clock hand means the hands of the clock covers equal distance in equal time. Now we are talking about non-uniform motion. Non-uniform motion means when the object covers unequal distance in equal time interval, that is called non-uniform motion. Example is motion of a car on a crowded street. Sometimes it goes slow, sometimes it's go very fast. So that will be the non-uniform motion. You can see from that example, this is the uniform motion example. Suppose you were traveling from this point to this point, and after each 5 seconds you cover same distance, that is 2 meter. So that will be the uniform motion. And this is the example of non-uniform motion. That means after each same time interval, 5 second, 5 second, 5 second, you have traveled different distances like 1 meter, 3 meter. After first 5 seconds you cover 1 meter. After next 5 seconds you cover 3 meter. Next 5 you cover 2 meter. That means it is unequal. You have covered unequal distances in equal time interval. So that is called non-uniform motion. Now we are talking about the speed. What is speed? Speed of a body is defined as the distance traveled by unit per unit time. That means speed is equal to distance traveled by time taken. So if we represent distance traveled is as s, so s by t will be the speed. So the SI unit of the speed will be meter per second. It is a scalar quantity, as the distance is a scalar quantity and time also is a scalar quantity. So the SI unit of speed, that means the speed is also a scalar quantity. When the body travels at a varying speed during a journey, when average speed is calculated as total distance traveled divided by the total distance, the total time. So average speed will be total distance traveled by total time. That means if you travel from A to B, that means total distance is 10 and total time you have taken, that is 2 seconds. So the total speed, average speed will be 10 by 2, that is 5 meter per second. Now what is velocity? Velocity of a body is defined as the displacement per unit time. So velocity is displacement per unit time. Displacement is a vector quantity. Now velocity is also a vector quantity. So velocity will be displacement by time. So the unit is same as speed, that is meter per second. Now what will be the average velocity? Average velocity is you can say that total displacement by total time, or you can say that the initial velocity, you can say the initial velocity plus final velocity by 2. What is initial velocity? Initial means that the when you start your journey, what will be your velocity, what was your velocity, and what will be the final velocity. That is the total of that is by divided by 2 is the average velocity. Now we are talking about acceleration. Acceleration is defined as the rate of change of velocity of a body. SI unit of rate of change of velocity of a body is called acceleration. So the SI unit of acceleration is meter per second square, and the formula to get acceleration will be change in velocity, so v minus u by t. V is represented here the final velocity and u is initial velocity. So suppose here I have given you an example that if you travel from A to B and after 5 seconds your velocity is 10 meter per second, and next 5 seconds your velocity increases by 10, that means 20 meter per second. Next 5 seconds your velocity is 30 meter per second. After next it is 40, that means the velocity increases after time. After some time the velocity increases. So that is called the velocity, that is called the acceleration. Now see, this is uniform acceleration. That means after each 5 seconds you have the velocity increases same amount, that means 10. Here also the increment is 10. Here also the increment of velocity is 10. Here also 10. So the change in velocity in each time interval is 10. So that this is called uniform acceleration. And what is non-uniform? If the change in velocity is not according to the time, that means here you see that the increment of the velocity is 10 and here it is from 10 to 50, that means the increment is 5. So here you can see that this 5 seconds the velocity increases by 10, but here in 5 seconds the velocity increases by 5 only. So that both are not same. So that is called non-uniform motion acceleration. Now you have easily understand that what is uniform acceleration and what is non-uniform acceleration. Uniform acceleration actually means that the same amount of increment of velocity, and the non-uniform acceleration means the different increment in velocity with respect to same time interval is called non-uniform acceleration. So acceleration is also a vector quantity, and as because there is change in velocity, so velocity is a vector quantity, so acceleration will be a vector quantity. Acceleration means change in velocity by time taken, and I have discussed that the unit of acceleration is meter per second square. So students, I have given you two exercise, that is two problems, and you can take the screenshot and do the homeworks, and this is one and this is another. Just a minute. So this is, you can take the screenshots from here and see the first. I'm reading the first example. Joseph jogs from one end A to other end B of a straight line 300 meter road in 2 minutes 30 seconds, and then turns around and jogs 100 meter back to point C in another 1 minute. What are Joseph's average speed and velocity in jogging from 1 to B and A to B and A to C? So this is the figure. From A to B and A to C, you have to calculate the velocity and the speed. Now the next one, that is Shourangshu, while driving to school, computes the average speed for his trip to be 20 km per hour. On his return trip along the same route, this is less traffic. There is less traffic, and the average speed is 30 km per hour. So what is the average speed for Shourangshu's trip? So I have given a hint, that is, you have to take the distance from home to school will be x. So if you can do the homework, you do, and next day I will give the PDF of the solutions. So thank you, best of luck.